Alright, welcome back. So in this video we're going to talk about factoring quadratic trinomials, okay? Factoring quadratic trinomials. Now, in order to factor quadratic trinomials, you do have to know how to do the greatest common factor. You need to be able to take out a greatest common factor, okay? Just know that, so if you are struggling with greatest common factor, make sure you go back and practice that skill, because that is going to be absolutely necessary in order to factor a quadratic trinomial, okay? So, factoring is really just undoing multiplication, okay? That's all that factoring really is it's undoing multiplication, okay? So as you can see, I have a little bit of a multiplication problem worked out. We had 3x plus 1 times 2x minus 5. I went ahead and multiplied this out to get 6x squared minus 15x plus 2x minus 5, which ended up becoming 6x squared minus 13x minus 5. So what factoring is undoing this multiplication. So being able to go from 6x squared minus 13x minus 5 back to 3x plus 1, 2x minus 5, okay? And factoring is an extremely important mathematical skill, okay? We're going to be using it in the context of graphing and solving equations and inequalities, etc., okay? So we definitely need to be able to factor, okay? And when we talk about factoring, we do need to talk about what the standard form of a quadratic expression is, okay? The standard form of a quadratic expression is simply ax squared plus bx plus c, where a, b, and c are all just actual numbers, okay? That's all that is, just actual numbers. So in this particular case, a is always your leading coefficient. It's a coefficient on x squared. So in this case, a is 6. B is always the coefficient on your linear term, so the one that's just on x. So in this case, that is negative 13. And c is always your constant, the one with no variable, that's negative 5, okay? Now, when we're factoring quadratic trinomials and we're working backwards, it can become a little bit difficult. The process is actually not too bad, though, as long as you have a good sense of numbers, okay? Because basically, when we factor quadratic trinomials, what we're looking for are two numbers that multiply to a times c and add to b. That's really what we're looking for here. Two numbers that multiply to a times c and add to b, okay? And I'll kind of show you why that's so important. So in this case, you can organize your information with an X, with a box. There's a bunch of different ways of organizing the information. I'm just going to go ahead and use an X. So I want to find two numbers that multiply to AC, which in this case will be 6 times negative 5, which is negative 30, and add to B, which is negative 13, okay? Now, that's what I mean by you have to have a good sense of numbers. You need to know your times tables. You should be pretty quick with your times tables, addition and subtraction, okay? This is absolutely vital, all right? Because I got to find these two numbers, and what these two numbers would be is negative 15 and positive 2, because negative 15 times 2 multiplies to negative 30, and negative 15 plus 2 adds to negative 13. Okay, so the way we use this is we bring down our first term and we bring down our last term, and we actually split this middle term into two pieces using these two numbers that we just found. Negative 15, attach your variable, positive 2, attach your variable, okay? And remember, factoring is just undoing multiplication. Take a look at what we have right here. When we multiplied this out, I got 6x squared minus 15x plus 2x minus 5. Look what I have. So as you can see, what this allows us to do is to find what those two terms were before we combined them to become negative 13x. Because we actually didn't change the problem at all. Negative 13x is negative 15x plus 2x. So this would just combine to negative 13x. So we're not actually changing the problem at all, because I know some people look at this and just in math in general go like, you're making stuff up. Like, what are you doing? But we're actually not. We're just splitting up that negative 13x, because negative 15x plus 2x is negative 13x. So we actually didn't change the problem at all. Okay, but now we still need to keep going, because when we're factoring, we should end up back with an answer like this. So I need to go a little bit further. And this is where the greatest common factor comes into play. Because what we do now is we use what's called grouping. We group our first two terms and we group our last two terms. And now what we do is we take out the greatest common factor in each group. Okay, so if I look at this first group right here, between 6x squared and negative 15x, the greatest common factor amongst these is 3x. So I can factor out of 3x. 6x squared divided by 3x is 2x. Negative 15x divided by 3x is negative 5. Between 2x and negative 5, I can't really factor anything out of these two. All I can factor out is just like a positive 1. There's not like a number that goes into both of these. They don't share a variable. So all I can factor out is a positive 1. And when I factor out a 1, nothing changes. 2x divided by 1 is 2x. Negative 5 divided by 1 is negative 5. And as you can notice, we have the same binomial happening twice. And this absolutely needs to happen. Now, just like we factored a 3x out of this group and a positive 1 out of this group, 2x minus 5 is what we call a common binomial factor, which means it's just a factor that we can factor out. So we can actually factor out a 2x minus 5. I'm factoring out a 2x minus 5. And what I'm left over with is 3x plus 1. And that's how we get our final answer. So as you can see, we get our final answer. That's how you can double check to make sure you got it right. If we were to multiply this back out, we get right back to what the original problem is. So as you can see, we are literally just undoing this multiplication, okay? And that's really all that factoring is. All right, so that's one example. I want to go ahead and take a look at another example. Let's say we had something like, x squared plus 14x plus 24. So just like before, nothing really changes. We're just undoing multiplication. Somehow we had two binomials that when they multiplied together, they got us x squared plus 14x plus 24. We have to figure out what that was. Okay, so we follow this process. A is 1, B is 14, and C is 24. So I have to find two numbers that multiply to A times C, which is 1 times 24, which is 24, and add to B, which is 14. Okay, and what these two numbers are 12 and 2. Okay, these are the two numbers. 12 times 2 gets us 24. 12 plus 2 gets us 14. So that's what we're going to use to split the middle, okay? So we bring down our first term. We bring down our last term. And we split our middle term using these two numbers. Positive 12, attach your variable, and positive 2, attach your variable. And now we factor by grouping, okay? Now we factor by grouping. So I group my first two terms and I group my last two terms. And just so you know, because this is normally a common question, some people ask, does it matter in what order these two go? Like, could I have 2x come first and then 12x come second? Yeah, you could totally have that. It does not matter in what order these two numbers go. I could have switched these two around as well. It does not matter what order these two go, as long as you have the correct two numbers, okay? So it doesn't matter in what order they go. So in this group, I have x squared plus 12x. All I can factor out is an x. All I can factor out is an x. So I factor out an x, and that's going to leave me with x plus 12 inside. And all I can factor out of the second group is a positive 2. When I factor out a 2, that's going to leave me with x plus 12. And as you can see, this happened once again. I need that to happen. I have a common binomial factor. X plus 12 happens twice, so I can factor out that x plus 12, and our other binomial is made up of the leftovers, which in this case was x plus 2. and that would be our final answer. And if you were to multiply this out, if you were to go ahead and actually multiply this out, you would be left back at our original expression, which is a way you can double check your answer. Okay, so definitely make sure that you have these skills down. I will go ahead and link another video with just a couple more problems with a few more explanations in different cases. Make sure you check that out if you need a little bit of extra practice, okay? But make sure you're ready, because we are going to have to be able to solve quadratic equations and inequalities by factoring, so your factoring skills need to be good, all right? So stay tuned for the next video.